Good afternoon, everyone. Thank you for joining us and welcome back. We're glad that you're here. I'm Steve.
And I'm Scott.
Together, we're Backyard Musing Science and Technology channel. And just in case you're a first-time viewer, we publish in the morning at 7 a.m. and in the afternoon at 1 p.m., Monday through Saturday. We take a break on Sunday.
Pacific time.
Time.
Left Coast time. Yep, left Coast time. So, but yeah, and we're still in our locations that we've been in for a few days. It's going to be this way for the next few days for me, and the next few months for Steve.
The next 60 days for Steve.
Yeah, until he checks out and heads back to join the Michigan militia. Going to join the Michigan militia. So anyway, it'll be a safer place. So until he runs for governor.
Right.
Then who knows what happens. So, or maybe you could start as the attorney general.
I need to have a law degree. I need to be
whatever. I mean,
the bar.
You all know that stuff, and this is not pointed to you personally, but the guy that's the attorney general of that state now, I don't know. I think Cameron could do a better job than he does. So, but you don't know. But anyway, here we go.
Astronomers have discovered a bizarre exoplanet with a giant underground ocean of magma that traps sulfur and may represent an entirely new class of worlds. Is it Mustaffar from the Mustaffar system? A team of scientists led by researchers at the University of Oxford has uncovered evidence of a previously unknown type of planet beyond our solar system. This unusual world appears to trap enormous quantities of sulfur deep within its surface inside a permanent ocean of molten rock. The research describing this discovery was published March 16, 2026 in Nature Astronomy. Would you like to know more?
Yeah, and just before I start reading my stuff, I just want to make everybody aware, hopefully, because I was talking to my grandkids last night, and they weren't even aware about the Artemis 2 liftoff the other day.
Yeah.
And that is a big deal. Yeah, this is a big deal. This is the first time in over 50 years that we've launched man this far into the into space, and it's setting up for another moon landing, which is very cool. So you're going to hear about. I'm sure we're going to talk about that in the future. So, but anyway, Artemis 2, we're on board here. All right, the planet, known as an exoplanet because it orbits a star outside our solar system, is called L98-59D as in David. It circles a small red star about 35 light years away from the Earth. Observations from the James Webb Space Telescope, which we love, along with data from ground-based observatories, revealed something unexpected. Despite being about 1.6 times the size of Earth, the planet has an unusually low density, and its atmosphere contains large amounts of hydrogen sulfide.
Oh, lovely to have a vacation, huh? Until now, astronomers would have classified a planet like L98-59D, and by the way, D means it's the fourth planet from the sun, in one of two ways. It could be considered a rocky gas dwarf with a hydrogen-rich atmosphere, or a water-rich world dominated by deep oceans and ice. However, the new research suggests that L98-59D does not match either of these categories. Instead, the planet appears to belong to a completely different class of world dominated by heavy sulfur compounds. I wonder how Star Trek would classify the planet. Class L? Class D?
I don't know. To better understand the planet, researchers from the University of Oxford, the University of Groningen, and the University of Leeds and ETH Zurich used sophisticated computer simulations to trace its evolution from shortly after its formation to the present day, covering nearly 5 billion years. By combining telescope data with detailed models of planetary interiors and atmospheres, the scientists constructed what is likely happening far below the planet's surface. I don't know how they do that, but that's fascinating.
Yeah, it almost kind of sounds kind of like snake oil when they're just through a telescope. They're trying to tell us, oh, this is what the core is made of, and this is what's happening below the mantle. I don't know. Their analysis indicates that the mantle of L98-59d is probably made of molten silicate rock, similar to lava on Earth. Beneath the surface lies a global magma ocean stretching thousands of kilometers deep. This massive reservoir of molten rock allows the planet to store vast amounts of sulfur within its interior over geological timescales.
The magma ocean also helps maintain a thick atmosphere rich in hydrogen and sulfur containing gases such as hydrogen sulfide, which H2S. Normally, radiation from the host star would gradually strip these gases away into space through X-ray driven atmospheric loss. Okay, this is way over my head.
Interesting, yeah. Over billions of years, interactions between the planet's molten interior and its atmosphere have shaped the chemical signals scientists detect today. These processes help explain the unusual atmospheric composition observed on L98-59d.
The researchers propose that this world may represent the first identified example of a larger group of gas-rich, sulfur-dominated planets that maintain long-lasting magma oceans. That's interesting that they would call that an ocean, because we're talking about lava, right? We're talking about lava and just hot stuff.
Probably the quantity of that stretching over vast miles and hundreds and thousands of miles.
Yeah. If that idea is correct, it would suggest that planets throughout the galaxy may be far more diverse than scientists previously believed.
Lead author Dr. Harrison Nichols, Department of Physics, University of Oxford, said, quote, "This discovery suggests that categories astronomers currently use to describe small planets may be too simple. While this molten planet is unlikely to support life, it reflects the wide diversity of the worlds that exist beyond the solar system. We may then ask what other types of planets are waiting to be uncovered."
Observations from the JWST in 2024 revealed sulfur dioxide and other sulfur-containing gases high in the upper atmosphere of L98-59d. According to the team's models, these gases can form when ultraviolet radiation from the host star, the red dwarf L98-59, drives chemical reaction in the atmosphere.
Meanwhile, the magma ocean beneath the surface acts as a huge storage system for volatile chemicals. It can absorb and release these gases over billions of years after the planet formed. This interaction between deep interior storage and ultraviolet-driven atmospheric chemistry helps explain the unusual properties scientists observe.
Simulations also suggest that L98-59d formed with a large supply of volatile materials and may once have resembled a larger sub-Neptune type planet. Over time, the world gradually cooled and lost part of its atmosphere, causing it to shrink. Interesting.
Scientists note that magma oceans are believed to be the initial state of all rocky planets, including the Earth and Mars. Because of this, studying magma oceans on distant planets can offer clues about the earliest stages of our own planet's history.
Co-author Professor Raymond Pierre Humbert, Department of Physics, University of Oxford, said, "What's exciting is that we can use computer models to uncover the hidden interior of a planet we will never visit." Never say never. Although astronomers can only measure a planet's size, mass, and atmospheric composition from afar, this research shows that it is possible to reconstruct the deep past of these alien worlds and discover types of planets with no equivalent in our solar system. Alien worlds.
Yeah. The Mustaffar system.
Okay.
New observations from James Webb Space Telescope are already providing an expanding stream of data. We love it. And future missions, including Ariel and Plato, are expected to deliver even more detailed measurements. The research team plans to apply their simulations to these upcoming observations using machine learning techniques. Their goal is to map the wide range of planetary stars beyond our solar system, stellar cartography, and connect those worlds to their early histories. Understanding how planets form and evolve could also help scientists determine which environments might be capable of supporting life.
Okay. Well, there you have it.
Love it.
Yeah.
I think these new worlds that we find, we should be sending a probe to them as quickly as possible so that in 30, 40 years, we can take a look at the planet, real-time data,
Yeah, and then maybe in that 30 or 40 years, they'll develop some kind of man-made or man-involved modules to land on Mars and some of the other planets in between this dwarf, and then they'll do it again, in the next 30 to 40 years. They'll get somebody out there. I think this is very cool. So,
I agree.
So it's like the drones, right? They can do a lot of stuff with drones that have no humans on them. So I love it. It's all good.
All right, folks. Thanks for joining us.
Take care, everyone. We'll see you tomorrow. Thanks.